A catalyst is a substance that increases the rate of a chemical reaction without itself undergoing any permanent change.
It does not affect the reactants at all, just speeds them up, making the particles collide into each other more rapidly. It also does not affect the products at all.
To show how a catalyst works, we will be decomposing hydrogen peroxide. Naturally, that process takes about 5 years. Notice the different sizes of the containers in the pictures. This is due to the time it has been sitting on the shelf, thus decomposing naturally. Our learning target is a catalyst. By the end of this, you should have a brief understanding of how and why a catalyst works on a chemical reaction.
This ties in with our Chapter 9 learning targets where we learn about various reactions. A catalyst can be used in any one of these reactions to speed up the reaction rate. For safety in this lab, we tied our hair back, wore goggles, had no loose clothing, and used a tub to contain the products. We also made sure to stand clear once the reaction started. With the products created being soap and water, we were able to wash them down the drain with plenty of running water. Procedure. Step 1. Gather materials. Step 2. Pour 150 milliliters of 30% hydrogen peroxide into a glass flask. Step 3. Add 6 droplets of liquid soap into the hydrogen peroxide. Step 4. Pour the liquid soap and hydrogen peroxide into the glass flask within the large plastic bucket. Step 5. Add a squirt of potassium iodide, the catalyst, into the hydrogen peroxide. Step 6. Stand back as the reaction takes place.
Okay, now put a good amount of catalyst in.
Wait, okay.
Okay, ready? Are you ready?
I mean, no. Sorry. Not ready.
Go. That's how it wants to do it today.
It's not, why is it inside snow?
It's the cup. Oh. That
I
was,
really like this one.
oh my god. That was like a volcano.
It's so white and fluffy.
Okay, this one is really cool.
It's just like the initial isn't like super cool.
It's just not volcanic, but this is awesome.
So a chemical of some sort, A, can go into B and C, but somehow it has to get above this, and that requires the activation energy. What a catalyst does is provide a little trap door, like right here. Let's call that D, so it can go from A to B and C easier with the catalyst D. So the delta H for hydrogen peroxide is negative 187.8. So it's an exothermic reaction, obviously, we just saw that. And so this is the delta H for if we had 1 mole of hydrogen peroxide, but we don't. We have 30% of hydrogen peroxide.
With the help of Mr. Corrigan, we figured out the moles per liter for 30% of hydrogen peroxide, which is about 9.8.
So with that molarity, we took 9.8 moles per liter and multiplied it by the amount of liters we had, which is 0.15 liters, and we got the amount of moles for the hydrogen peroxide we had, which is 1.47.
So then times the moles by the delta H, we get 276 kilojoules, which is the energy released in our equation.